Hello, everyone. Welcome to ITS 350. So today we are going to continue with, today we have a lab. We're going to continue with the XOR problem. And as we said, we're going to try to implement the CBC mode of operation. This would be the last algorithm that we're going to cover, as I said, as we wrap up cryptography. I will do this exercise, try to understand everything in this code, okay? Even though I'm gonna write most of it, I do want you to try to understand as much of it as possible, given that next week you'll be using a Python library called PyCrypto. So although the code there is very easy to do, by now hopefully you're starting to get used to the code. I will give you a lot of examples, but on Tuesday, but still I will need you guys to do some of the work, okay? But today I'll go through this lab as an exercise, and this will be a lab that you'll have to submit, and so we're just gonna run through it, okay? So I'm going to go ahead and start up the virtual machine. Okay, so I'm going to start up the VM. And I think this code we had already started to do. So I'll probably just start with the code that I had and just we'll work through it. Okay, so I'm going to share my screen. Yeah, the lab is going to be due a week from today. Okay, so I need to share the VM. All right, there you go. So that's the virtual machine. And now let's just, so you should be seeing the virtual machine right now. So I'm going to go ahead and open. I always have a hard time opening this chat. Okay. All right, so let's share again. All right, you should be seeing, as I said, the virtual machine at this time. I'm going to open up a terminal. And so we can navigate to the desktop. And we're going to go into that folder, ITS 350. And we have the XOR Lab. Okay. So we're going to just start with that one. I'm going to make a copy of it. So I'm just going to make XOR. CBC XOR. So now we should be able to use that one instead. Okay. So this is the script that we had before. And I'm just going to make this a little bit smaller. All right. So we have our, if you remember the functions that we had the library for random numbers. Then we had a function for generating the key. And then we had a function for encryption. And I already discussed this, how the XOR operation works. Basically, at the heart of it is the caret. So you should, hopefully you tested all of this and you made sure that everything was working fine. And then I have the decrypt over here, right, and the XOR. So today I'm, and then I had the main where you have some string. So you'll have to make this a slightly longer string. You can calculate the length of the key based on the length of the message. That's how I did it before, but now my message will have to be much bigger than the key. So that means that you have to break it into blocks, probably blocks of the size of the key itself. And then if the last block is not of that size, you're going to have to pad it, okay? So the plan today is I'm going to give you more code so that you can solve this problem. Remember, I think I've had this question a couple of times via email. Remember, the goal is to implement the CBC mode of operation through this script, okay? So that's the homework. You just have one problem that's due a week from today. I'm not gonna do all of it, but certainly I'll give more code today and let you guys finish up the rest, right? You should be able to do it. Here we can print the key, then we take the message and the key and encrypt, all right? And then we have the cipher, we can print out the cipher, and then we take the cipher and the key, decrypt, and then get the original message. And I think we ran this and everything worked out just fine. So let's go ahead and just test for that. Okay, so we run it and everything works out. We get the string back. So that's exactly what we want. Now we can get into more of the details of this, right? So probably the first thing we want to do is we have gen key, we have encrypt and decrypt. So now we probably want to take plain text and break it up into blocks, right? So we want to find a simple way of doing that. Once we have all the blocks, then we probably want to have some kind of a for loop so that we can perform the encryption, okay? So that's really the plan. So how do we proceed with this? We're going to need, let's say, let's just start thinking about what we need. We're going to need a padding function. So basically, define, let's call it padding, right? And that's our function. This will take a block, let's say, and block length. Right? Or maybe we should be more specific here and say block to pad. Okay? So block to pad, you can say that. All right? That's one of the things we need. We just have to figure out how to do that. All right. Then we have so we need to take the message and we want to try to break it into blocks somehow. Okay. So now there's a lot of ways in which we could do this, certainly. So you can think of multiple ways. Okay, so let's see. Break message. So let's think of one example here. Let's say so this is just, as I said, there's multiple ways in which you could do it. But let's say define break message into blocks, right? So that's what we want to do. All right, so this would take the message, the original message, and we also want to have the block size. Okay, so I'm going to specify that in there. 1, 2, 3, 4. All right, so now we want to do this function should return an array called list of blocks, right? And it's going to be empty first. We know message is what contains the information, but it's longer. So what we want to do now is, in Python, this will be very easy to do. We can just iterate with a step size. So we can say for I in range, and then we're going to say, we're going to say that we want to go from 0 to what? To the end of the message, right? So length of message. And the step size is going to be block size. Okay, so that way we can kind of slice the data. So the idea is that, it's like we're saying, we're going from 0 to 6, right? And then the next block will be 7 to 12, and the next block will be 13 to 18, and so on, right? So that's what we are going to try to do here in this example. I'm going to comment this out, leave it as a note. All right, and so we're going to slice through the data, basically. So now I'm going to go in here, 1, 2, 3, 4. And every block now, it's going to be from the original message. So I'm going to take block, or you could call it temp block. You grab the original message, and now you can basically iterate just by using sort of the same technique that we used in the first encryption substitution problem. You go from I. So you go from I to I plus block size. Okay, so when the index is 0, I is going to be 0, and I plus block size will be, let's say the block size is 10. So it's going to go from 0 to 10. Next iteration, it's 1. Sorry, the next iteration will be not 1, but block size 10 because of this, right? So it's going to go from 10 to from 10 to, let's see. Yeah, no, right. So 10, it would be from 10 to 10 plus 10, so 20, right? Next iteration, I was thinking, I don't know why I thought that plus was a multiplication. So next iteration 2, or the second iteration, that's actually going to be 20, because remember, it goes from 0 to the length of message by block size. So the indices, if block size is 10, would be 0, 10, 20, 30, 40, 50, 60, and so on. You can always, if you want to understand this a little bit better, I would recommend that you just do, I'm going to comment this out, but you can try print I, and then that'll give you some insight into what's going on. So this allows us to get block from 0 to 10, then block 10 to 20, then block 20 to 30, then block 30 to 40, because it's always I is going to be a multiple of 10, and then 10 plus 10, whatever it is, you add 10 to it. So that way we can slice the data out in blocks of size 10. So that gives us our data. Now the question is, what happens if we have a block that is not size of block, maybe like the last one probably. So in that case, we need to have some kind of a, you know, a conditional there. We're just going to say if length, right? If length of block is equal to block size. Right, so that's the case when it's good. So all we have to do is add it to the list. So we're going to say 1, 2, 3, 4, list of blocks dot append. Right, so list of blocks dot append, and then what do we append? We append block. Okay. 1, 2, 3. Right. Else, if it's not 1, 2, 3, 4, if it's not the size of the block, what does that mean? It means that it must be
Needs to be padded.
padded. Very good. It needs to be padded. So how do we do that? We can probably just create a function. So we're just going to say padding, and we're going to say block padding, and then here in the padding function, the parameters should be the block to pad the block, and we needed to specify the block length. So that's block size, basically. Right, and then that'll give us the new block. And then once we have the new block, we just add it to the list. So we're just going to say list of blocks dot append. We append block. And it is basically that simple. So it should be that simple, all right? So now the question is, we need to figure out the padding function, right? So that's really what remains here. So we're going to go ahead to the padding function up here. Colon 1, 2, 3, 4. All right, and now we are going to need to figure out how to pad this. So we're going to need the size of the block to pad. So let's say you know, smaller size, you know, some variable name. Couldn't think of anything more. Oh, that's better. So smaller size, and then here we can definitely get the length of the block to pad. So let's stay with the analogy that we were doing. Let's say that the size of block is 10, and then the block to pad is 6, right? So that means that we need to add 4 characters to it. Okay, that's what we would need to do. So block would have to be, because this is a string, right? These are strings, so we can concatenate the characters. So let's try that. So we're going to say, we just need to know how many characters we're going to add at the end. And these are going to be spaces, so that it doesn't really make much of a difference. So we can say, call it, you know, padding size, and that's going to be block length minus smaller size, right? And that would give us the difference, 4. And then once I have this padding size, then all I need to do is say for I in range, and then now it would be padding size, colon 1, 2, 3, 4, and then 1, 2, 3, 4. So now all we have to do is we have to take block to pad, and it's going to become block to pad equal block to pad concatenation, which is just a plus when you're dealing with strings, and then we just add a space at the end. So that should take care of everything, and that's it. So now we can try and see if it works. So I am going to need a longer string here. So what do I need? Now I need to call the function break message into blocks. Oh, so we didn't finish. So padding is not done yet, first of all. So let's do, once we've padded the block, we return block to pad. Now it should be of size, the appropriate size, which is 10. You can always check that. Then padding over here returns block, and now the function, this one, 1, 2, 3, 4, needs to return list of blocks. List of blocks. So it needs to be returned, and that's it. That's pretty much it. I'm gonna just add a break line. A little bit small. All right, so in theory, this should work. So we just need to call break message into blocks. So where would we do that? We would do that, here in the main. Right, we take the string first, and we take the string, actually take the string there, and now we can say, okay, I want all right, we're going to have to make some changes here, but around here, basically, I would call that function. So I'm just going to say break message into blocks. So we need to figure out, so now let's go back to the function. Let's kind of understand it a little bit better. So break message into blocks takes the message and the block size. So we need to figure out what the block size will be. And then it returns list of blocks. So we need to have over here, list. This is a separate list outside of the scope of the function called list of blocks as well. And we can just initialize it to nothing if we'd like. And then over here, list of blocks. All right. So now we need to provide the message. That's simple enough. We just have to say my message. So that's done. We just need to modify the message. Did I write a different name? Which message? They're all my message. What do you mean? Three up top. Three up top. What does that mean? Which one do you mean? I'm sorry, I don't. Message, so there's, you mean this message? The one in break message into blocks? Is that the one you mean? Yeah, in the padding function. So remember, you know, yeah, remember the names can be different, right? Because the scope of a function allows you to have a variable with a different name. It doesn't matter. We're going to plug in my message in here, and message will take it over in this function. But it is the, so we break, what do we break into blocks? The whole message. Do you mean this? Where is message defined? This, you mean, where is this one defined? It's defined right there as an argument for this function. But when we use it, we're going to take my message, which is this one. So this is my message, right? And then my message will plug in here into break message into blocks. And then when we, so that my message, then when we go into break message into blocks, is this message. And then this message will make its way into padding, but as blocks. I get it. Okay. All right. All right, good. Yeah, so the similar names, yeah, but they're not the same actually. So that's, I actually, this is one of the reasons why I, in practice, always like to change the names a little bit so that you don't think they're the same. All right, so where were we? So we've done break message into blocks. Right now, I'm just going over the logic. There might be a few, I might be missing a few parameters here and there, but so let's keep going. Okay, so we did my message. We need to change this to be longer, okay, guys? So you'll need to make this, you know, I suggest make this, you know, long, because I'm just going to write like characters here, but you guys should make like a long sentence, okay? All right. So that's something that makes sense. Probably shouldn't use gibberish, given that, oops. This is a string. All right, I'll let you play with that, but just something long, longer than the block size. Now, the key thing is we need to figure out what's going to be the size of the blocks. And I would say, just to make things simpler, make it equal to the size of blocks. So then basically here, instead of saying length of my message now, because we can't say that, just pick a number. So length of key, let's go with 10. Or actually 6, given that my sentence is not that long. All right, so I'm going with, or 8, right? You know, be consistent with the byte size. All right, so we'll have length key 8, okay? And then list the blocks, then list the blocks. So now list the blocks takes, or sorry, break message into blocks takes the block size, which is also the same as the size of key. So therefore, I can just plug in for everything length of key. Okay? All right, so that, if everything is correct with that function, it would return for us a list of blocks. All right, and then now we have our blocks. So then we also generate the key. So gen key. So now we have the key. We can print it out. Just gonna add another line here for make it more readable. All right. And now then we just want to try to encrypt. So we're gonna take the encryption part, and basically what we would need to do now is we would take we would need a list of cipher blocks, right? That's what I think. List of cipher blocks. And then in here now, we're going to do a for loop for block in list of blocks, because those are ready to go, right? Oops. And so now, what do? As I have a block, I'm going to encrypt it. So 1, 2, 3, 4. This is no longer cipher text, but cipher block to be more consistent. And then in here, I'm going to have, instead of my message, which was the whole message, now I have block. Do you see that? So that allows us to break the data. The encrypt function also takes the key, which I already have, so that's good. And then as I encrypt a block, what do? I have to add it to list of cipher blocks. So I'm going to do dot append. And what do I append in here? I'm going to append cipher block. If I look above, I want to check the encrypt function. So I'm just going to double check that everything is okay. It takes a plain text, which in this case is a block. Okay. And then it runs through that block and through the key, which are both the same size, and it XORs them. Okay. So hopefully that gives me the cipher blocks. Then I can, I don't need any of this. I can just comment it out. You can always at the end, you can always at the end, if for debugging purposes, you can always do print list of cipher blocks. So you can do that. All right, that should give you the list. You can do a length of this list. You know, you can double check on all those things. Same thing then for the decrypt now. Basically, list of decrypted blocks. Right, and then you're going to do for cipher block in list of cipher blocks. List of cipher blocks. And now you can, you can just go ahead 1, 2, 3, 4. So let's call this decrypted plain block. And we're going to decrypt cipher block using the same key. You see that? All right, and that's the key. And then again, so now we have the decrypted one, and now we need to add it to our list. So we can say list of decrypted blocks dot append. and then we add to it decrypted, encrypted plain block. So we're going to do that. And then now we should be done with the decryption process, at least in theory. And then we do, and then we can finally just print out decrypted, no, sorry, list of decrypted blocks. Are there any questions?
Not really.
Huh? Not really? All right. So this is what we have. Do you guys see any errors or anything that might not work? Are we missing something?
I don't know if it's not necessarily an error. I guess I do have a question. In CBC, you're supposed to use like an initialization vector and stuff like that. Are we and using that with the XOR operation? Is this supposed to touch on that at all, or is this just to demonstrate the basic concept?
Exactly. Good catch. So the one I just wrote is not CBC, right? What is it?
The DCB.
That's what I wrote. Still need to make it into CBC. And you'd be surprised at the fact that it's not that complicated. So good catch. But let's run this one just to see if I have any errors before we move on. So that was a good catch, and we need to address that. All right, so, oops. Is there another enter in here? All right, so I'm going to do clear, and then I'm going to run it. All right, there we go. So what do we have? We have the encrypted one, right? List of encrypted. And then, do you guys think it decrypted correctly?
Yeah, it looks like it's kind of hard to read with it saying the byte array stuff, but the actual message seems to be there.
Let's try to get rid of those. Maybe typecasting to a string will do it. So we just need to, let's see. All right, check the fact that it, you need to check all those things, right? Does it have this, size 8, all those little details. So where we are adding here, let's see if we just do string and if it gets rid of that byte array stuff. All right. So I'm going to run it. Clear. Oops. Okay, better, right? Looks better. This is a long string. This is a long string on October 15, 2020. This is a long string. And I think that's what it was. Yeah, this is a long string on October 15, 2020. This is a long. Okay. As I said, play with this, make these certainly longer, something a little bit more readable. I'll leave that to you guys. What else? We can do a join here. So I'm just going to do space dot join list of decrypted blocks so that it makes the list into a string. A little bit better. All right, so now we have our string. We have the encrypted version of it. You would have to do the same. Keep in mind, guys, that we're going to have a practical exam. And I may give you scripts like this one where you're going to have to do these things and you're going to have to send that message encrypted to your friend, okay? So just keep that in mind that the practical exams are demos. And so you're going to have to demo all of this. So I will post a video on on the channel, so you can just get it from there. Yeah, so on Tuesday I'm gonna do more exercises, and then on Tuesday I'm gonna do more exercises, and then on Thursday next week we will begin the practical exam. Okay, that takes a while, and as I said, it's just like a lab. It's just like a lab. At least one part of it is just like a lab, but you have to demo. The other part, it's a lab that you have a shortened period of time, and you submit, and then you also have to demo. So another question is, will the video be available tonight? Yes, so the videos, I always post the videos. I have to post the videos. So that I can finish what I'm doing the day. So they get posted to the YouTube channel first, and there you can get them right away. But me adding the link to the calendar, that usually takes me a couple of days because I only do it at the end of the week where I do everything. So I'm going to do for all class. So it, you know, if you look for the channel, you'll see the videos there tonight. Wait, hold. Yeah, so the practical exam is the Crypto Lab. Yes, correct. But it's basically an exam that covers everything that we've covered from the beginning of the semester to now. You have to implement all of those encryption ideas. Another exam is, the first exam is about Crypto, right? I don't know what you mean by that question, but it's all gonna be the Crypto library and something like this, like what we're doing. That's why I'm taking a lot of time with this. All right, any other questions?
Could you open up the file again and using nanos? I didn't quite catch the part where you did like the quotation marks and then you like added stuff to that. I missed that part. To make it to where it displays like normal.
Right. That I did join. So you can do.
Oh, okay, it was join. I missed like part of it.
But like I said, I will post the video.
Yeah, that's fine. Oh, okay. Thank you.
I like to do this sometimes to make it more readable. It's like a jQuery kind of a approach. All right. Yeah. So everything seems to be working, right? Double check. Your job. I've given you the code, but your job is to ensure that you're encrypted. Remember that on the practical test, I could say next week, okay, use ECB and encrypt a message for confidentiality and send it to your friend, but also exchange the key via asymmetric encryption. Okay. So Crypto will help you. You could also try to use the Openssl commands. The problem is you would have to type everything manually, whereas the Crypto will do some of the things automatically for you. All right. Let's see. So this is ECB. Everything else, I think, is correct now. So the question, and it's not really that hard, as I was saying, it's not really that hard. So you just have to figure out now. Oh, this is, yeah. We got how to break the blocks. We know how to iterate through the blocks. We've got that done. So so I ask you guys now, you've seen the algorithm that we have here. What else do we need to make it from its current state as ECB into CBC?
First thing is we're going to need to be able to perform 2 XOR operations rather than 1.
Right, we need to do 2 XOR operations. We also need, as somebody said, the initialization vector. So the okay. So I may on the exam, you know, on the practical, not give you anything else. So what would you do as far as the initialization vector?
Basically generate it the same way you generate the key, because it needs to be a random, or like a pseudo random value. So you would just use the same method you used to generate a key.
Exactly. Very good. So I would probably recommend just copying the code and just calling it generate initialization vector, but it would be the same code. You know what I mean? So generate IV. So then here we can call it length of key again. So length of key. And then we're going to do, as you said, the exact same thing, right? 1, 2, 3, 4. Return byte array. And then we can say urandom length of key. And that's it. All right, so now you have your initialization vector. So then we can go down here. So where we generate the key, might as well say IV generate IV. And the parameter would be the same one, length key. You can see it works out pretty well. So now you have your initialization vector. And now what do you have to do? What's the next step?
You need to XOR it with the block, with the first block of the message.
Right, right. So we have to do that. So now we need to another XOR, exactly. So where do we do that? Here, right? In the block, list of blocks.
Yeah,
right?
yeah.
Okay, so you guys so think about it. So let's take instead of me writing it here, let's take a 5-10 minutes. You guys try it on your own. Think about it. How would you do it? All right. And that's really all we have left. We know already how to take a message, break it into blocks, pad it. We know how to XOR. All we need to do now is we need to do this. But the trick is that every block needs to be XORed with the IV, and then that block becomes the initialization vector of the next block, and so on, right? So you have to think about that for a second. So think about it for a few minutes, and then try it on your own. Any ideas? Although this part seems straightforward, there's a little bit of logic that you need, of additional logic. So what would you guys do? What do you say? You have, what do we have? We have an initialization vector, we have a block, and we have a key, right? We can only perform an XOR between two things, right? So what are you going to do? What do you suggest?
Maybe like a second or like another function for the XOR operation, since we're adding another XOR operation, or maybe modifying our existing encrypt function to perform two XOR operations.
Sure, all valid, all good. So someone asked me to repeat. So all I'm saying is, currently we're encrypting, the way that we have it is encrypt via ECB. Now we are encrypting CBC. As we learn, CBC involved what? So maybe this is a moment when I need to remind you of things. So let me go to the whiteboard. All right, so I think you should be seeing the whiteboard right now.
Yeah.
So the idea is, if you remember with CBC, what do we have? We have the block. We already have those. You have a key. You already have that. You already know how to XOR. You have that. However, we need, for this to be CBC, we need to have that initialization vector, right? So that means, you know, we have this, we have the IV, and then now, this is the plain block. This comes in. The output of that gets XORed with this. That gives us a cipher. However, in the next iteration, we have, let's call it plain block 2. And we do this, we would follow this same mechanism here. And this gives us yet another cipher. But what's missing? What's missing here?
You have to replace the IV with the cipher of the previous block.
Right. I have to do something like this, right? You see, that's the trick that we're trying to implement in the algorithm right now. You know, one last time, plain 3. You know, we got that. We got that. We know we have the key. So that's not a problem. Oops. We've got a cipher over here. The trick is we don't have that IV again, so it must be replaced with the previous one. So it's going to be like that. And that's what we need to do, okay? That's what we're trying to do here in our code. And so we need to go back to that idea. All right, so what I'm going to do is I'm going to share. All right, go back to the code here. You should be seeing now the script. All right, I'm going to scroll down. And I know that I need to store the IV here, right? So something needs to happen here. So the idea, based on what I showed in that diagram, I would take, let's call it cipher 1, you know, for lack of a better name. And let's just do an encrypt of what? The block and what?
The IV.
The IV, right? We can do the IV. We can do the IV here, exactly. And so I'm gonna do IV. Once I get that, I get cipher 1. But then I need to do a second encryption, and this time with what? With the key. So here, instead of block, what would I write?
Cipher 1.
1. So that sort of takes care of some of it, right? And then I get cipher block, and then cipher block should be good, and it gets appended to the list. However, what else would I need to do?
Well, if doing it this way, won't it encrypt with the IV every single block?
Every single block, right? So we need to change the value of IV for the next iteration. Since this is over here, we can change it, right?
So set IV equal to cipher block, right?
Exactly. You see that? So the next iteration, we take the next block, which is correct. We would take as an IV the previous cipher block, which is correct. We get cipher 1, which is correct. Then we take cipher 1, encrypt it with the key, gives a cipher block. We add it to the next element, and then we do the same. Now IV gets replaced with the current cipher block. Go back and so on. Do you guys see that?
Yeah.
And that's pretty much it. We're not done, but because remember, we have to decrypt also, right? So right now we're only going in one direction, although the logic is pretty consistent. So we just have to think now. We kind of have to just like work through it and figure out what are we missing. Now, one thing that's going to happen is that, and this is not a logic thing, but it's just going to be a coding thing, that if you remember, this block is a string, but whereas this one is going to be a byte array, if you remember that, right? That's the way that, so you had, Dakota, you had suggested 2 functions, and I would agree with you. And it's not because the logic is not the same, it's just the fact of, for this byte array. Do you see what I'm saying?
Right. It's different data type.
Different data type, so we should probably account for that. But that's the only thing. Otherwise, this will error out, I'm pretty sure. So let's try it. Yeah, so see, it doesn't like it. It's saying when you encrypt cipher 1 on the, so in the second encryption, return byte array, you know, that expected string of length 1, but in found. So that you can see the error there. So we need, and that's just, you know, a coding thing. We just have to fix that. So I'll fix that. And then, but the idea, the logic is really there. So this is where we are. Okay. And then we have to think about the decryption. I will leave the decryption to you guys. So start thinking, at this time, we should have the ciphers, right? So start thinking about how you would do this in reverse. Okay. right, so we probably should call this one. We know that from message to IV, that's like the key. So that should work just fine. It's really here where it doesn't like it. So I'm going to create encrypt2. All right. I mean, I could also make a function that checks, but I think it's just easier to do that. So then I'm going to go over here. And then now I'm going to say define encrypt2, right? This would be cipher1 and key. So a couple of things to try. One of them is just try this. Try making the whole thing a string. So you could say, you could try 1, 2, 3, 4. Return, oh, sorry, say cipher1, which is currently a byte array string. Let's start there and see if that works. So then this would be cipher1. Okay, then we're going to move over here. And now we just have to repeat the other what's above. So we do return byte array, byte array. And then we're going to say list, and then within the list, ORD plain text, oops, I.
Wouldn't it be cipher 1 I? Because we don't have plain text in this one.
Parentheses. It would be cipher1. Cipher1. And then I, caret, key here, I. Oh, I forgot to close this. So this should have been here, which means that that doesn't have a parentheses. And then we do for I in range length of cipher1. All right, so let's try this one and see what happens. That should be encrypt2, which I think I already called that function. Yeah. So hopefully it won't error out. Let's see. Although it won't decrypt correctly. Okay, good. So what happened here? When you guys look at this, what do you conclude? What's your conclusion? Just by looking at this, what do you conclude?
It's definitely not decrypting, right?
Right, it's not an error, but no errors, it ran, but it's not decrypting correct, and that's because we encrypted, we did 2 encryptions, but only we're still doing just 1 decryption, correct? So we need to do the whole process.
Right.
So that the way that works is like you have a message and you add a component of the IV, then you add a component of the key. Well, on the decryption, it's the reverse. You have to take out that component of the key, then take out that component of the initialization vector, and what you have left is should be the plain message, right?
Right.
So let's try that then. So let's go ahead and try that one. So I'm going to go ahead here And now what do I need? We'll probably have to do the same thing with decrypt, but we'll think about it in a sec. And then here, let's just say, so it would have to be over here. Here. All right, so we're gonna do cipher block. So now we have to think about this in reverse, right? Or how do we, no, not in reverse, but how do we decrypt? We have, see, this is almost like the Feistel network example. Remember that one? So we need to kind of think now in reverse. How do we do that? So let's go.
You
Go ahead, please.
you would need to take the, you would have to start from the end and take the last block, XOR it with the key, and then XOR the results you got there with the previous block.
All right. So I have these three, correct? I have these three. So I have C1, C2, C3, right? And now I'm going in the direction of the plain text. So the question is, what do I need? Okay, what do I need? I have the key, so that's a good thing. So I could take the key at any time, XOR it with those ciphers, right? And I get to this stage on all blocks. I could even do it in parallel. It's gonna work. The trick is though, the trick now is how do we go in that direction? So we need the IV or the initialization vector. Okay, for the first one, this one, what does it use? The IV, correct?
Right.
Now the IV is something that we actually could have because we keep it. So that's not a problem. The problem is this next one, right? So can we decrypt the last one? Just alone? No, right? Because we need the cipher. Oh, but we do have the cipher, don't we? We do have it. Because it's this one, C2.
Yes.
You agree?
Yeah.
So we got the key. So it's easy then. So we have the cipher 3, we have it. Key, we have it. The previous cipher, we have it. For C3, it's just C2. All right, so then for C2, let's see if it checks out. C2, I have the key. Okay, C2, I have the key. What is the IV of C2?
C1.
And then for the last one, I have C1, this one. I have the key, no problem there. And then the only thing I need is the IV, and I actually have that as well. Do you guys see that? So I have everything I need. Okay, so that means it's always, if this is C3, this is C2. So it's always like, it's like, you know, cipher I XORed with cipher, what, I minus 1, right? It's always like that. And so that's what we need to do in the code. Right, so that should be, so the diagram helps out a lot. So let's go now back to our code, Linux machine here. Okay, so we've got, what we need is in here, in cipher blocks. List of cipher blocks is what we need. So we can iterate through all of these. Probably again, just use the IV. Oh, let's take that IV and let's just say decrypt IV, right? And then we assign to it IV, and that way we can just use it down here. So that now I'm going to say cipher block, or actually just add, I'm going to do the same, just add two functions. So I'm going to say decrypt 1, and it will be equal to decrypt, and what is it? Cipher block, right?
Yeah, and then you'll need the key first, right?
Or the key, right? Okay, yeah. So we use the key, and that gives us decrypt 1. So then this one becomes now, right, decrypt 1. Decrypt 1. And then this one needs to be XORed with what?
The previous block.
But in the first iteration, because remember, this is the first cipher block. This is the first.
The IV then.
So decrypt. So I just changed the name. Decrypt IV, right? And then once I do that, that's decrypted. First iteration is done. No problem. But the next iteration, it's going to need a different decrypt IV, correct? Because the cipher block will be correct, the key will be correct, this will be correct, but the decrypt ID needs to change. So what is this? Now remember, what we are past the first iteration, we're in the second one, right? So we're in the list, we're in C, let's say the list has C0, C1, C2, so we're in C1. So now the IV is C0, right? So how do you get that one?
You set it equal to cipher block?
You set it equal to, yep, that should work. All right, very good, excellent. That sounds about right. And now probably the only thing we need to do is this decrypt is still going to give us trouble, right? So let's see. So this one would have been byte array. This would have been byte array.
It would be the second one, I believe, because the top one is like the original one we had, if I'm not mistaken, right?
It actually gives you a plain text. So it should. So I think decrypt 2 in this case is the one that's correct, because decrypt 2 takes a byte array, which is the previous one, which is the way it used to work, but it's supposed to return a plain text. So really, I think the function we're going to need to change is decrypt to go from byte array to byte array. So let's take a look at that. So let's go to the top. And here are the functions. If you look at it, it says decrypt, right? And it takes decrypt. See, and it takes a cipher text and converts it back to a string through the lookup in the ASCII table. So this one should be correct, in my opinion, too. So really, what we need to do is the first one. We need to think about that one a little bit. Define decrypt cipher text key. 1, 2, 3, 4. All right. So the question here is. I would argue that all we need is to remove that CHR. So let's see how it works out. If not, we'll fix it. But return byte array, right? And then list. So it should be cipher text I caret E I for I in range length cipher. So if there's an error, it's here. It's this. This would be the error. All right, so let's try it out. At this point, if we did all of this correctly, it should decrypt. So let's see. Yeah, it works. Do you guys see that?
Yeah.
Any questions? Okay, I'm going to show the bottom of the code again. Like where? Here? The decrypt, I guess. And that's it. So really, we just had to, because of the data types from byte array to string, we just have to play with it a little bit. But overall, that should be it. As you can see at this point, that little logic takes care of the decryption. And look at how straightforward the code was actually. You know, it wasn't really that, although it might have seemed really complex, it wasn't so bad. Are there any questions?
No, not really.
So you guys should run this, okay? Please go ahead and run this code. This is the lab. As you can see, I mean, there's not, you know, basically I just want you to try longer strings and just make sure it's working, right? So remember on the practical exam, I could use code like this to ask you to do things.
And then for the report that we have to turn in for this lab, do you just want screenshots of the code and us explaining like how it works, or?
It's an easy lab, I realize that. So just screenshots of it working for sure. I need to make sure that you got this code to run and then that you try different strings. And yeah, you can explain the code a little bit. As I said, this is more of a warm up for, you know, what we're going to be doing next week. But this should give you, I think, enough practice. Okay. All right, so I don't know if I've created the Dropbox for this. Let me see if I've done that. All right, so it should be XOR. Okay, so I haven't created. So I'm going to add the assignment. You should be seeing this. I'm going to call this the XOR Lab homework. So today is the 22nd, so it's going to be due on the 29th by 11. Complete the attached XOR Lab as discussed. Implement CBC mode of operation using the XOR code. Which, you know, we're pretty much done. So just make sure you implement this. This should be very easy points. All right, and then this is due the, you know, I'll keep it open until the 31st. All right, so that should be it as far as the homework assignment is concerned.
Is there a specific amount of string sizes that you want us to try, or just try like a couple and
Try a longer string. I had a student once that took images, and he read the image of the square and the circle, and he tried with both ECB and CBC, and basically with code from scratch, he was able to do the same thing that Openssl did. So you guys can try that. I'm not making it a requirement. I'll give bonus points to whoever gets that done. So this is implemented here. Let's see. There's some questions in the chat. Let's see. All right, so some questions here. So yeah, so the block size should be smaller than the size of the message, right? That's the idea. Remember, you can't make a key as long as the message because it's not practical. So then you have to use smaller blocks. You can try things that are bigger, of course. Try longer strings. You could also read a lot of text from a file into a string. Okay. So for that, you know, just create like a function. You know, you would do, let's say, create a text file, and then you could say, and this would, I would recommend actually, now that I remember, I would recommend that you know how to do this, because also in the practical, I may just give you a text file with a lot of data in it. So for instance, you can say read text file, right? And then you would say, okay, 1, 2, 3, 4. So then, you know, you can plug in here return, and it'll return data as a string, right? And then over here, you provide just a file path to the text file. And so therefore, over here, you can say, you know, file equal open, and then you specify your file path, and then you know, read. I'm just going to read. And then you read your files. So then you're going to say data as a string, and you're going to take f dot read. You read all the contents as a string, and then don't forget, before you leave to close the files, f dot close. All right, and then you use this function. Basically, you would use it. Where would you use it? So you need to use it here, right? No, here, my message. So now my message would receive the contents from reading the file. Make sure you do that. Create a long text file, put a lot of data in it, read it into here as a string, and then do the process. Okay? Oops. All right, there's some questions in the chat. Is file path the directory of R? All right, so down here, R just means read. So here you can specify whenever you have a file, whether you want to read, write, or append. File path is just the file path of your file. So for instance, if, you know, double quotes, it's just a string. So so let's do this. So in the file system, I can do pwd, and then now I have a full file path, right? And I also have, so, you know, I can create a text file. So nano, my secret message .txt. Keep in mind, you know, something like this is what I'll do on the test. So my secret message, you know, hello. And then today is 10/22/2020. And that's the secret message. So then I'm going to do this. And then I can do pwd, and then I know the full path where it's located. So then you can just copy that. Remember my secret message. So now we go, oops, not that. We go over here, and then the function, I think I put it way down here. And then now, that's the path, / my secret message. All right, and then here then, I can just make a call to the function. Say temp message, and that's going to be read text file, and then you're just going to say file path, and then you would want to print it just to see that you have something there. All right, so I'm going to try that. And there it is. You guys see that?
Yeah.
One thing you might want to do. So one thing you might want to do is the following. I would recommend getting rid of the new line characters. So sometimes you have these strings have new line characters. You might want to get rid of them. And the way to do that is, so I think if I remember correctly, it's just
Excuse me.
yeah, please go ahead.
One thing I did notice in the print statement at the bottom where you have the dot join, if you actually delete that space, it gets rid of a lot of the funky spacing when it prints out your decrypted message. That's just, it's one thing I noticed when I was messing around with the code. I just thought I'd say something.
Yeah. What this does is if you want to put commas in between all the elements in the list, you could do that. If you wanted to put 3 dots, you know, so it allows you to put things in between the elements of the list as it joins it into a string. So yeah, great catch. All right, now over here, I think we can just do replace. I believe this will work. If not, there's a replace function in Python. I just don't remember off the top of my head, but I think it's something like this. And then it just, the new line character looks like that. It's basically whenever you have an enter in your text. So with this, you know, it's a string, you probably, it's like an encrypted message, you might want to replace it, and then you just replace it with nothing. So you put 2 double quotes with nothing in it. So let's see what happens here. It's something like this. I just don't remember exactly the function. Oh, that worked. Yeah. So you can see here, I got rid of all that. See how you had all this spacing, and then here it's gone. Does that make sense, guys?
Yeah.
Right, great. So remember, what I may do on the practical exam is I'm just going to give you a decrypted message, and it's going to be something that I may decrypt or encrypt many times with many algorithms, many keys, many initialization vectors. You will have to, like, it's like peeling onions, right? You're going to have to remove all the layers. And so what I may give you is I may just give you a file. That's all, which is what makes sense. I'm going to give you like private keys, public keys, maybe, or not private keys, right? That would be wrong. I would give you my public key probably, and there might be a hidden encrypted key somewhere, and then you need to get that to get to the, and I may give you the encrypted message and so on, okay? So we practice with this code today. Make sure you run through this, and you know, it's complete, but make sure you understand everything. And then on Tuesday, I will give you more, like library code. We'll do more examples. And then probably on Thursday, we will start working through, you know, those labs, which are, you know, what I'm calling the practical exam. Remember, it's going to cover everything that we've seen this semester as far as all the primitives of encryption. All right. And that's pretty much it from me today. I posted the assignments. The Dropbox is ready to go. The code is finished. This video will go up in about 2 hours. It'll be in the channel, so you can practice the code. As you know, everything works. I'm gonna run it one more time just to double check. See, everything runs. You get the cipher, then you get the file, then you get everything that you need. So the practical exam, when will you demo it? You will demo it possibly start demoing on Thursday, or if not, the week after, so the next week. Okay, like I said, it's really 2 exams, because one is where I have the messages hidden. The other one is just really you guys communicating. Remember, you need to have a partner, so I would recommend, you know, find a partner or somebody that you work with before. Be ready, so you'll be working together for the next 2 weeks on this, okay? And you can start reading the PyCrypto Lab that's already posted. First come, first serve. As far as demoing, it's not really a presentation. You don't have to present the topic. You just really have to, I'm gonna ask some questions. Like I'm gonna say, okay, as I said, it might be a little bit more challenging via this medium. In the classroom, I would just sit with, you know, the 2 people, and then I would say, okay, now achieve confidentiality, now achieve integrity, now send the key, you know, and I would ask you a few questions here and there. So we'll see how it goes, but it's whoever's ready to go can go first. That's basically how it works. All right, any other questions?
I don't think so.
All right, great. All right, so we can stop here for today and just submit this assignment, easy points. Practice though, and then on Tuesday, as I said, we will begin with the PyCrypto. All right.
All right, cool. Thank you so much.
Have a good weekend.
Thanks, you too.